Hey guys, so welcome. So what you're looking at here is the schematic that I posted. I want to go through it with you so that you'll begin to understand what I've done. So this is the aluminum and iron. I've got the aluminum wrapped 90 degrees around the iron, of course. And then what I've got is I've got a 90-degree winding, actually right here, actually going counterclockwise of strands. And I've actually got that at 36 gauge. You can see a thin wires. I've got 10 of them. And then on top of that, I have a winding using hookup wire. It's stranded wire, kind of like thin lamp cord. And that goes on top of that. And then going around inside the middle on top of the aluminum iron piece. And of course your aluminum is not touching the iron except in one spot. Your iron has shrink tubing all the way around. But this is the collector on the interior as well. And that's made up of, on this build, hookup wire as well. Okay. So this goes all the way around, but I didn't draw the whole thing out. So this is the front. The aluminum and iron is actually inside of here, but again, I didn't draw that out. So I figured I'd explain it for you. So what we've got here is I've got from the PNP, and it's got to be connected like this. If you connect things opposite of what I've got here, you'll eliminate about 2/3 or 4/5 of your power. So the PNP, from the PNP signal generator to right here, goes around, comes out here, goes through here, hits a diode, produces current across the resistor. Current begins to flow this way. The electrons generate on this hookup wire. Oops, sorry, I didn't mean to move it here. On this hookup wire right here, the electrons generate, this is 40 feet of hookup wire, generate more amperage, and this becomes a amperage loop. This is the 24 LED bulbs that you see. And this right here is a return path to the negative, okay? And this whole path on it from the PNP, okay, which has come from the signal generator, which the positive goes to a signal generator, comes through the PNP. All this right here has a total right now of 2.75 milliamps. That's right. I eliminated the secondary hookup that I was running to the piece of iron from the PNP like I used to. It didn't need it. It actually hurt the effect now that I've got going, I believe, properly or close to properly. So I removed that. It dropped my input by a sixth. So I'm at 2.75 milliamps, 36 volts DC. And that 2.75 milliamps is coming back here. Okay, so this is the circuit, 2.75 milliamps. Boom. Now, in here, we've got current. And without this connected up here, you saw I was doing 15 milliamps, okay? And these were really bright, nicely lit. Now, what I found is up here, I started to connect the strands using a diode, and each strand has 7.4, 7.5 milliamps of current on it. I've connected 2 of them, and I got 15 milliamps. Actually a little more with my little setup here because I'm running it through. So it actually puts out 17 milliamps. Drops the amount of current down here to about 6 milliamps. These are still lit, but obviously only about half as bright as they were before. Now, if I disconnect this up here, there is no power going through, no 2.75 milliamps, and it will not work. Okay, this part will not work. Nothing will work. So this bottom part here, this has to go back home. And that's your 2.75 milliamps, 36 volts. Now, this top part that I have now generated 17 milliamps, just using 2 strands. I've got 10 strands, so I have more to hook up. But these I've just got hooked up with my little alligator clippies that I love so much. And tomorrow I'm going to solder it up, make it nice and clean, and just make it better. Then I'll start adding more of the wires. I'm going to tape them off and just keep them from touching. So what's happening here and why this is working like I believe it should be, I really think that this is not perfect, but pretty close to the circuit potential, this part right here, is this. What we've got right here is we've got DC current being generated on the 90-degree strands, 2 of them, turns into DC, which actually there's no current unless you turn it into DC. Turns into DC, gives me current. The DC is going to come to the resistor because the DC cannot go through the capacitor. This is a 1UF capacitor right here. So the DC comes this way through the resistor. The AC goes through the capacitor into the collector and is going to run this way, okay, the opposite direction. So the DC is going to run this way. So I've got AC going one direction, DC going the opposite direction. And the interaction of the two increases the amount of free negative electrons, which gives you a larger magnet, which gives you more generated current. Okay? So this is 2 of them. That's why the capacitors there's I'm using that to split the signal. So AC this way, DC this way, DC goes this way, AC goes in the opposite direction within the same wires. Pretty darn cool. And it works. So that's with 2, each one giving me about 7.4, 7.5 milliamps. Tomorrow I'm going to hook up some more. What else? That's about it. Then that just feeds on through. And then you take the power off the resistor right here. Now I'm measuring amperage with the amp meter between these 2 spots right here. The capacitor has to be there for it to function again properly. And what else? This is a 100 ohm resistor, 100 ohm resistor. You can measure voltage across the resistor if you want to measure power, or you can measure amperage. What I'm after right now is amperage, because I'm going to continue to combine all of these until 7 times 10. I should be, if I'm right about this, and it's not just a 2-wire phenomenon, then I should have about close to 80 milliamps by the time I connect all this. Okay? So anyway, that's where I'm at. That's what I'm working with. That's what I've seen to date. Now, this is a very finicky thing. Didn't mean to do that. Let me fix my mouse. Don't go nowhere. All right, there we go. So what I was saying is this is a very finicky thing. Stephen said they went through 300 different styles of collectors to find the one that worked the best. I'm just getting going. The first thing is understanding the circuit potential. And for me, the big deal is splitting the signal so that I've got DC going in one direction, AC going in the other. That's huge, really huge. And I'm generating current on strands, at least 2 of them. And again, I saw the same amount of current, identical on both of them. It wasn't like one gave 7 milliamps and the other one gave half a milliamp like I've seen before. This was equal. Pretty amazing. So I'm pretty excited. I'm pretty stoked. This is where I'm at. Still need to figure out why when I boost the voltage with the DC, a DC converter, it's not doing what I think adding more batteries will do. So anyway, that's for another day. But somehow we're going to need to boost the voltage on up, even if I have to keep adding batteries. I'm not even sure a DC power supply would function properly. I don't know. There's something different, and I just can't figure it out. But anyway, I need Michael's help on that one. So great news. That's where I'm at. If any of you guys want to build it, to test it where it is, just let me know. I'll give you a hand, help you out, suggestions, whatever. Pretty cool so far. This piece is still going to be eventually high pressure, low pressure, like I showed you guys. And so I'm really excited about that, but that's going to be, again, for another day. This here, for speed, just had hookup wire. So anyway, tomorrow I'm going to clean these up, solder them up, keep adding strands, see if I can't continue to increase the power here. And we'll do that with 10 strands, and then I'm going to figure out my next steps after that. Thank you for watching. Have a great night.